Imagine your favorite camera. Now imagine adding a special lens to it. This lens gives your camera new abilities like taking wider shots or zooming in closer. Plugins are like lenses for your software. They add new features and capabilities without changing the core program. Just like you can swap lenses on your camera, you can easily add or remove plugins to customize your software experience. This essay will explore the world of plugins, explaining how they work, their benefits, and some things to consider when using them. Whether you're a seasoned developer or just starting, understanding plugins can help you unlock the full potential of your software. Plugins are built on the idea of modularity. This means they are separate pieces of code that work independently from the main application. Think of it like building with Lego blocks. Each block has its own function, but you can combine them to create something bigger. Plugins communicate with the main application through well-defined interfaces called APIs, or application programming interfaces. These APIs act as bridges, allowing plugins to access and use the main application's features while remaining independent. One of the most powerful aspects of plugins is dynamic loading. This means you can add or remove plugins while the main application is running without needing to restart it. Imagine changing lenses on your camera while still taking pictures. That's the flexibility dynamic loading offers. This is possible because plugins are loaded into the application's memory when needed. When you no longer need a plugin, it can be unloaded, freeing up system resources. Dynamic loading makes software incredibly adaptable, allowing you to customize its functionality on the go. Plugins and the main application are loosely coupled. This means they are connected but not overly dependent on each other. The main application provides hooks or extension points where plugins can attach themselves. These hooks are like designated spots where plugins can insert their functionality. This loose coupling offers several advantages. It makes the software easier to maintain because changes in one plugin are less likely to affect the main application or other plugins. It also simplifies development, as different teams can work on different plugins simultaneously without interfering with each other's work. Section 5. Provide real-world examples from browsers to games. Plugins are everywhere in the software world. Here are some examples. Web browsers, ad blockers, password managers, and grammar checkers are often implemented as plugins, enhancing your browsing experience. IDEs, or integrated development environments, use plugins to support different programming languages, debugging tools, and version control systems. WordPress relies heavily on plugins to add features like contact forms, SEO optimization, and social media integration. Many games allow players to create and share custom levels, characters, or gameplay modes using plugins, extending the game's lifespan and replayability. Media players, codec packs, which enable media players to play different audio and video formats, are a classic example of plugins. These examples highlight the versatility of plugins and their ability to enhance a wide range of software applications. Section 6. Describe how plugins work. A simple example. Let's illustrate how plugins work with a simplified example. Imagine a photo editing application. The core application provides basic functions like cropping and resizing images. First, interfaces. The application defines an interface for filters, outlining methods like apply filter image. Next, plugin implementation. Developers create plugins that implement this filter's interface, adding their own unique filters like sepia tone or black and white. Then, plugin loading. When the application starts, it scans for available plugins and loads them into memory. Following that, user selection. The user selects a filter from a menu, triggering the application to call the apply filter method of the corresponding plugin. Finally, filter execution. The plugin's code executes, applying the chosen filter to the image. This simple example demonstrates how plugins extend the core application's functionality without modifying its source code. Section 7. Highlight benefits, easy to add features, clean core parallel development customization. Plugins offer numerous benefits, making them a popular choice for software development. Easy feature addition. Plugins allow developers to add new features without modifying the core application, simplifying development and reducing the risk of introducing bugs. Clean core application. By keeping non-essential features separate, plugins help maintain a clean and manageable core application, improving maintainability and stability. Parallel development. Different teams can work on different plugins simultaneously, speeding up development and fostering innovation. Customization plugins empower users to tailor the software to their specific needs and preferences, creating a more personalized experience. Section 8 mentions drawbacks, complexity, security, performance. While plugins offer significant advantages, it's essential to be aware of potential drawbacks. Complexity. Developing and managing plugins can introduce complexity, especially as the number of plugins grows. Security plugins can pose security risks if not properly vetted, as malicious plugins could compromise the main application or user data. Performance, loading and executing multiple plugins can impact performance, especially if plugins are poorly written or resource-intensive. Section 9 mentions popular frameworks. PF4J OSGI Spring plugins. Several frameworks simplify the development and management of plugins in Java. PF4J, a lightweight and easy-to-use framework for creating plugin-based applications in Java. OSGI, a mature and comprehensive framework that provides a modular architecture for Java applications, enabling dynamic plugin loading and management. Spring plugins, an extension to the Spring framework that offers support for developing and managing plugins using Spring's dependency injection and aspect-oriented programming features. These frameworks provide tools and abstractions that streamline the process of building, deploying, and managing plugins, reducing development time and effort. Section 10 Conclusion. Plugins enhancing software extensibility. Plugins are powerful tools that enhance software extensibility, allowing developers to add features, customize functionality, and empower users. By understanding the concepts of modularity, dynamic loading, and loose coupling, you can unlock the full potential of plugins and create more flexible, adaptable, and feature-rich applications. From web browsers to games and enterprise software, plugins play a crucial role in shaping the software landscape. As you continue your journey in the world of software development, remember the power of plugins and their ability to transform your software from good to great. Hit the like and subscribe for more videos on enhancing your software development skills.